We are working on transformations, section C of chapter 5. On the reading, for y equals f of x plus b, the effect of b is to translate the graph vertically through b units. If b is greater than 0, the graph moves. Well, let's see if we have f of x plus 3, for example. What does the y value equal? Well, it's always 3 more, so it moves up. If b is less than 0, the graph moves down. For f of x minus a, the effect of a is to translate the graph horizontally through a units. If a is greater than 0, the graph moves. Let's see, we're going to look at Desmos. So we can see that we have an a parameter here, a slider, which changes x to x minus a. And if we look at the red M here, we can see that when a is positive, it moves the graph to the right. And when a is negative, it moves the graph to the left. So we can answer that now. Okay. Right. Left. Okay. For y equals f of x minus a plus b, the graph is translated horizontally a units and vertically b units. In this case, it is translated by the vector, and we would put here a, b. So basically that means that the x-coordinate is affected by a, and the y-coordinate is affected by b. Let's continue on to some problems. Sketch the graph of f of x equals x squared, and then we're going to graph some different variations of that. So first we'll just draw axes here, kind of in the middle. And then we'll draw in red the original function, f of x equals x squared. So maybe this is kind of fuzzy. It's been a few weeks since we did quadratics, but basically you have the points 0, 0, 1, 1, 2, 4, etc. So there's our parabola, the original parabola. For B, it says on the same set of axes, sketch the graphs of, and then they give us some different variations of that. And just like when you graph the parabola, if you don't remember what it looks like, you just like graph some points here. So you graph -1, 0, 1, 2, etc. And so that's when you put those points, x coordinates in there, and then you get the y coordinates out, like that, for example. Okay. Now you do the same thing with each one of these. So for example, if you have f of x plus 2, which is the same thing as x squared plus 2, then you just make a little table. And you say, okay, in this case, I'm going to have, when I put in -1 for x, I get 1 plus 2, which is 3. For 0, I get 2. For 1, I get 3. And so you can see that you're getting a graph that is higher than this one. In fact, the vertex is at 0, 2. Okay. So it actually looks kind of like that. So this one we did in blue. And then the next one it says, what about f of x is minus 3? And that would be the same as x squared minus 3. That you can fill out a few points and you'll see that that lowers the graph by 3. So like all the corresponding points are lowered by 3. Okay. What is the connection between the graphs of y equals f of x and y equals f of x plus b if b is greater than 0 or if b is less than 0? So again, if we look at the reading from above, we know that when b is positive, the graph goes up, and when b is negative, graph goes down. Okay. Number 2, for each of the following functions f, sketch on the same set of axes the graphs of y equals f of x, y equals f of x plus 1, and y equals f of x minus 2. We can already kind of predict what's going to happen with these because we just saw that when you have plus 1 or minus 2, that raises the graph by 1 or it lowers the graph by 2 vertically. Okay, so we're just going to do A and C, but this 2 to the x should be pretty fresh in mind. It's an exponential function. We can put like if you put 0 in there, it's 1, and you know, if you don't remember what it looks like, you could put a little table, and then you would have 0, comma 1, for example. 1 plugged into there would give you 2, 2 would give you 4. Okay, so that gives you the right side. 1 comma 2, 2 comma 4. Okay, so it looks like that with an asymptote. And then what if you were going to do f of x plus 1 in this case? Well, then all the y coordinates would be plus 1 to their original values. So you would have something that looked like this, and the asymptote would be y equals 1 instead of y equals 0. Okay, so that would be the f of x plus 1. What about f of x minus 2? What would that look like? Well, that would just be all the points would be 2 units lower than they are here. So you would have an exponential function that looks kind of like that with an asymptote at x equals negative 2. Okay, now let's do this function here, 1 over x. So first we're going to draw the axes, and then we'll draw the original function. And if you don't remember what this looks like, it's a hyperbola. You may, make a little table and put in some values, like 1 is going to be 1, negative 1 is going to be negative 1, 0 is an asymptote. So you're going to see by plugging in some values that it is a hyperbola. Okay, and then what does this look like when you raise it by 1? Well, all the corresponding points are raised by 1, and then it looks kind of like this. So the asymptote is now at y equals 1, for example. What about when you lower it by 2? What does it look like? Well, when you lower it by 2, the corresponding coordinates are all lowered by 2. And then the asymptotes are also lowered by 2. So the asymptote is now at, oops, that doesn't look right, does it? Lowered by 2, so it's here. So the asymptote is now at this line here, which is at y equals negative 2. Okay? All right. Now, you're kind of getting the hang of this, right? On the same set of axes, graph f of x equals x squared, y equals f of x minus 3, y equals f of x plus 2. Okay, so basically they're saying, hey, graph the parabola again, y equals f of x minus 3, and y equals f of x plus 2. Now be careful, this is not what we just did. What we did before is we added the number outside of the f of x. Now we're actually putting it inside the f of x. So this is a little bit more tricky. First we're going to draw the axes like we did before. And then we're going to draw our regular parabola, which looks kind of like that. Okay. And then let's try to see what it looks like to do f of x minus 3. Okay, so we're going to do f of x minus 3. How do we find f of x minus 3? Well, we put x minus 3 into the x squared. So actually we're going to have x minus 3 squared. Okay, and if we graph that, we will see that the parabola in this case is not centered anymore, because like if we put the value 3 in there, we'll get 0. And if we put 2 in there, we'll get 1. And if we put 4 in there, we also get 1. And we can see that we're going to get the parabola again, but now it's centered at x equals 3. Okay, so that's what we get when we do x minus 3. And what about if we do x plus 2? Well, x plus 2 would have a tendency to go the other way, right? So now if we do x plus 2, then the center of our graph is actually going to be at, oops, and that's not negative 0, it's 0, okay? The center of our graph is going to be at negative 2 now. Okay, so if we put in negative 2 in f of x plus 2, which is equal to x plus 2 squared, we'll see that the center of the graph is now at negative 2. So actually the parabola would look kind of like this. Okay? What is the connection between the graphs y equals f of x and y equals f of x minus a if a is greater than 0, if a is less than 0? Well, when a is greater than 0, it's the purple case, and it shifts right. Shifts right. And if a is less than 0, it's the blue case, and it shifts left. Okay? All right. Now number 4. For each of the following functions f, sketch on the same axes the graphs of y equals f of x, y equals f of x minus 1, and y equals f of x plus 2. Okay, and we are just going to do a and c. What I'll do for you here is x cubed. Okay, x cubed, when you graph it, you can try a few points here. Like for example 0, 1, negative 1, 2, and you can see what happens to these points. It ends up being something like this. Okay, it already goes off the screen there. But x cubed looks kind of like that. And what about when you have f of x minus 1? What happens? Well, we just saw above that when you have f of x minus 1, it shifts to the right by 1. Okay, and it might be counterintuitive because if you see negative 1, you might think that it shifts to the left, but it shifts to the right by 1. Okay? Okay, and then what about when it's x plus 2? Where does it shift? Then it shifts to the left by 2. Okay? So putting x minus 1 or x plus 2 shifts it to the left or right depending on if the a value is positive or negative. Remember, the a is not negative 1, but it is 1, right? Because the negative is outside of the a. Okay? So you can do this one on your own. We already graphed a hyperbola above, so you remember what that looks like. Let's look at this one. Well, in this case, we're combining both translations, the horizontal translation and the vertical translation. So let's see, we're going to do A and C. Okay, and you know, if you get bored of doing hyperbolas, you can go ahead and do this one. It doesn't matter which one you do, just pick 2. So when you have a parabola like that, and you are going to do an x minus 2 and a function plus 3 translation, you're just doing 2 translations at the same time. Remember, the plus 3 is actually a vertical translation, so you are going up by 3. And then the minus 2 looks like it would be to the left, but actually it's minus a, and a equals 2. When a is positive, you're actually going to move to the right by 2. So your new function is going to be exactly the same, except for it's going to be shifted up 3 and to the left by 2. Okay. What about if you have x plus 1 and minus 4? Okay, so we'll try that one. So x plus 1 looks like it would be going 1 to the right, but remember that the a value is actually minus a, so it's actually negative 1, so you're actually going to the left by 1. And then negative 4, the b value is going down by 4. So the resulting parabola is going to look like, kind of like this. Okay? All right. And you could do this one on your own, or the e to the x if you prefer. Copy these functions and draw the graph y equals f of x minus 2 minus 3. So you are going to change this graph here, and this graph is a pretty crazy looking thing. You can't draw that, you can't write that as an equation, of course, because it's, it's not curved at all. But just analyze this, and if you have x minus a plus b, you can see that the a here is 2, positive 2, and b here is negative 3. So a tells you which direction it's going to move in the x direction. It looks like it's going to move 2 to the right, okay? And b tells you which way it's going to move in the y direction. It looks like it's going to move 3 down. So this whole graph is going to move 2 to the right, 3 down. So every single point is going to do that. 2 to the right, 3 down. 2 to the right, 3 down. So one of the points would be here. Okay, and then the rest of it, I think, would look kind of like that. Okay, so that is what this is going to look like. Okay. 7. The graph of x squared minus 2x plus 2 is translated 3 to the right to g of x. Find g of x in the form ax squared plus bx plus c. So if you know that it's going to translate 3 to the right, that's the same thing as saying f of x minus a, and a with 3 to the right would be positive 3, right? So it would be f of x minus 3. So what you could do is you could just say, okay, g of x is actually equal to x minus 3 squared minus 2x minus 3 plus 2. And then you just need to do a lot of algebra to simplify this and get it into this form again. And you do that by doing FOIL. And then you would multiply this out. Okay, and then you would just combine all those terms to get this form here. Okay. 8. Suppose that x squared is transformed to x minus 2 squared plus 2, x minus 3 quantity squared plus 2. And this should look familiar to you, because remember when we did quadratics, we had a form that looked like this, and h and k were the vertex. Okay, so find the images of the following points on f of x. Well, 0, 0 is the vertex of x squared. Guess what the vertex is in the new graph? It's going to be 3, 2, remember, because h and k is the vertex. You can also think of it this way. We remember whenever we have x minus a and plus b, that we know that the translation is going to be a is the x translation and b is the y translation. So we're moving over 3 and we're moving up 2, for example. So all these points can be found by adding 3 to the x coordinate and adding 2 to the y coordinate. So you can see that, like this one, for example, would become negative 3 plus 3 is 0, and then 9 plus 2 is 11. Okay? Where x equals 2. Well, x equals 2 would become x equals 5, right? Because 2 plus 3 is 5. Let's go to b. Find the points on f of x which correspond to the following points on g of x. So now we're going the opposite direction. We would be going down 2 and then to the left 3. Okay? So instead of adding 3 to the x and adding to the y, we're doing just the opposite. We're subtracting 3 from the x, we're subtracting 2 from the y to go back to the f function. So, it would be minus 3 from that one, minus 2 from that one, so it would be negative 2 comma 4, for example. So that's all you would do for the rest of those. Okay?